So we're going to continue our frame of reference notes, and we're going to start talking about how do we know something is moving. Well, let's look at the first picture here. You can see some precursor of swans coming up, but in this picture you could probably guess that the swan, the water, the air, the wind, grass, anything like that's moving, but it's still harder to tell in a picture. But you have some inferences again because you have a frame of reference. You're comparing the neck of the swan to the grass. Now if we use the animated swans, we can tell that the swan is moving moving the pole because the pole is changing distance in comparison to these two trees behind it. It's also changing distance in comparison to the chest of the swan. By the way, that sign says caution, aggressive swan. It's kind of ironic, right? This swan, you can tell its neck is moving compared to this distance it is from the front of its body to the back of its body. Also, it's moving from one part of the greenery to another. So the frame of reference is the objects around it. The swans down here, the little baby cygnets, are getting closer to the grass and to the shore. So again, in this case, the frame of reference would be the shore, and what would be moving would be the swans or the cygnets. Up here, the neck is moving, and the frame of reference would be either the swan's body or the baby swan, the cygnet, or you could also have to say the frame of reference was the grasses behind it. The frame of reference here, what's moving is the sign. The frame of reference is either the trees in the background or the swan's body. So frame of reference really allows us to determine what's moving compared to something else. And we know something's in motion when its distance from another object is changing. So officially, an object is in motion when its distance from another object is changing. Okay, I've said it twice. Remember it. Go back, read it 4 or 5 more times. In this case, it's again a picture, a still picture, but we can infer what was moving. I don't think the apple was moving. I think the apple was the frame of reference. And compared to that apple, I believe the bullet probably entered from the right and exited through the left and then is continuing through. We know stuff is in motion. We can tell we're in motion by a combination really of our eyes, what we see, and our inner ear is where our balance is really. So if you close your eyes, sometimes it's harder to balance. Our inner ear, if you have inner ear issues, it can really mess up your balance. You can get something called vertigo. And the other thing that helps us with stabilizing is our muscles. We can tell if we're flexing. So it really takes our brain to control our muscles as it responds to what our ear senses for motion and our eyes see for motion. And motion sickness occurs basically when there's a disconnect. When your eye and your ears are disagreeing with what you see, that's motion sickness, which we try not to get. Now let's look at the frame of reference here. From the guy's point of view, the ball is moving forward, but it's only moving forward for him a couple feet and landing in the bucket in front of him. From the viewpoint of someone on the side, that ball is going up and over the bridge and landing on the other side of the bridge. It's traveling a much greater distance depending on your point of view, depending on the frame of reference. The frame of reference from the car, it's a pretty short distance. But remember, that truck has forward momentum. He's kicking in forward momentum. And so from the outside, it's like this huge arc that ball is traveling, not a short arc. What you're going to be doing now are 2 things. We're really going to look at reference point and that frame of reference. A reference point is just a place used for comparison to determine if something is in motion. And what you're going to want to know, even standing still, we're moving at a phenomenal rate of speed. Remember, we're rotating on our axis, we're revolving around the sun, we're spinning around, with our other planets through our Milky Way galaxy in our spiral arm, and the whole Milky Way galaxy is flowing up. This is showing you multiple directions. If you could see it a little better, you'd see that Earth is spinning. It's revolving around the sun. The sun is spinning around our solar system, and it's a little harder to see the last motion, which is our solar system, our galaxy, flinging outwards. So just to put this into perspective, right now standing still, our frame of reference has a hard time understanding this, but the Earth spins at 0.5 kilometer a second. We revolve around the sun at 30 kilometers a second. Our solar system galaxy is spinning around the Milky Way at 250 kilometers per second, and the whole Milky Way galaxy is being flung outwards at 300 kilometers per second. That's incredibly fast. The problem is the distances are so vast in space that it's a couple light years for our closest star to get to us. Or, well, no, that's not true. Our closest star is the sun, and that takes 8 minutes to travel 93 million miles for that light to reach us. But the next closest one after that, you're talking light years for it to get here. So the thing is, our comparison to determining that we're moving, we get it, but we just don't perceive how fast it really is because our frame of reference is so far out, it's hard to compare. It's kind of like if you were driving in the Dakotas or a really flat plain and it's night and there weren't a lot of streetlights and you see car lights in the distance. If there's nothing to illuminate to say, hey, look, that tree is really small in the headlights, or hey, wait, that tree is super big, I'm only seeing the that trunk of the tree, that vehicle must be really close, I better not pull out in front of it. There's a lot of accidents on those flat plains because without a frame of reference to see the height of the tree that's being lit to tell us how far those lights are away. So people sometimes erroneously pull out thinking that the car is much farther away and really it's really close and they get hit. So our frame of reference to know that things are changing is, well, the sun, we know we are spinning because we have the sunrise in the morning and it sets in the evening, although really it's us spinning on our axis that is night and day. We know that different constellations come in view at different times of the year, so that's a frame of reference that does change, so we know we're progressing through our revolution around the sun. But other than that, it's really hard. It's hard to perceive this hurtling through space, but we are. But frame of reference really takes that into play. So you're going to do two things next. There's one more frame of reference video that I need you to watch. Bear with me, it's very old, but it's an incredibly good representation of showing frame of reference. And then you're going to do the activity that is frame of reference. So you've got two more things to do after this set of notes. And as always, if you need help, ask.